Thank you, Al, for that warm introduction, and thank you all for being here with us today. Because we can't really do all this work that has been done by the NASA team, the tremendous amount of work on ATD-2 and the Integrated Arrival Departure Surface work, without all the airlines and the FAA and the airports and all of our partners. Because, I mean, I would say long time ago we used to, and this is a very, very long time ago, multiple decades ago, we were doing really wonderful job, but most of it was done in lab. We would polish the rock to the completion and then sort of try to deliver it at the FAA loading dock and say, ta-da, here we are, we're done. And that didn't work out so well because we need to work things early in the concept, in the concept formulation phase, so that essentially the requirements that are user-driven are baked into the final product. And that's how the team worked this concept that you see over the next couple of days. Very heavy airline and FAA participation right from the get-go. And that's why it's been so successful, because the requirements are baked in and the product is essentially what delivers to the user needs. I don't want to spend too much time here, but I just wanted to give you a brief overview of sort of a broader picture of who we are within NASA and how this project fits into it. But I'm not going to go into details of ATD-2. I'll let Al and Sean and company do that for you over the next 2 days. So first of all, airspace operations safety within NASA. That's one of the programs within the NASA Aeronautics Research Mission Directorate. As you know, we have 4 research mission directorates. One is aeronautics, one is space ops, we have exploration, and we have science. So we are one of the 4. Primarily, we are all aviation oriented. So we're one of the programs which is ops and safety, primarily dealing with flight deck safety elements as well as ATM. And then, of course, we have several other sister programs that do vehicle development, so wings and engines and so forth that you all operate. As an example, would be some of you that operate, say the MAX or the 787, and you have those engine chevrons on your aircraft. That originated from NASA. Winglets, I know Airbus adopted it first, but NASA was behind it a long time ago. And so things like that, essentially we say that NASA is almost in the DNA of the aviation industry. You don't see a NASA meatball logo on the products, but a lot of the things that are there originated with us. Within the program, we have 4 projects. One is ATD, which is essentially high TRL, technical readiness level, tech demonstrations of products with partners. And ATD-2 was one of the sub-projects within it. We have air traffic management exploration, and that is a new project we have stood up, and it will continue forward, which is essentially geared towards how do you transform the NAS into a more service-oriented architecture. And I'll speak to that in a moment. We have system-wide safety. That, again, is going away from the current mode of operandi of the diagnostic safety to a more prognostic safety mindset, which is heavily data-driven. And it's sort of in-time or near real-time operations. If I may be, overly overstating something, you look at the current safety paradigm, which has served us really well, but unfortunately, it's sort of like something bad happens. There's a huge investigation. We find out what happened, and then essentially a rule, reg, or procedure is put in place as don't do that again. It's sort of safety by exception a lot of times. But we want to move towards, how do you move towards data-driven, where you're looking for data that's coming off of the FMS, off the flight deck, off the air traffic management system, and say, can you look for precursors to incidents before something bad happens? And of course, UAS traffic management, or UTM, which is the small, low-altitude UAS operations. And looking at the room, I'm pretty sure that's going to be not something that you guys are too fond of. Unfortunately, that is something that we still have to deal with, because we got to make sure that we keep them away from all the commercial transports operating at low altitudes in terms of your arrival departure procedures. In terms of the broader accomplishments that we have done, the first project was ATD-1, which was completed and tech transferred. In a nutshell, it is how do you enable RNAV RNP approaches at congested airports during peak times while metering. I know it's a mouthful, but that was the gist of the project. Because I know all of you have been equipping for ADS-B as a mandate, and RNAV RNPs are out there. And I know a lot of you can't use them during peak metering times because you can't keep you on that RNAV RNP rail, lack of a better word. Controller has to take you off it and vector you around to essentially absorb delay. But through precise speed control, we're able to do that. And that was tech transfer to FAA, and it's going to be implemented as part of their TBFM rollout starting in Denver 2020, I believe. I think that date is still holding. I'll look to my FAA colleagues to correct me if that has slipped. But that essentially will have a huge impact for you all in being able to use TSAS within TBFM to essentially use RNAV RNP approaches. ATD-2, which is what you're all here for the next couple of days, is in a nutshell, I mean, I guess, Sean, I hope I'm not misspeaking, but it's sort of as much a non-stop taxi as possible with a precise gate pushback time to then be able to sort of meet an overhead stream slot. That's pretty much what we're trying to do. At what time should you push back from the gate in order to do that with low fuel consumption? And that is nearing completion, and that's what you're all here for the next couple of days. And you will hear a lot more on it. And of course, huge savings, and as you can see, the numbers are there to speak for themselves. Just like TSAS as well, it's about $500 million forecast by FAA at least in terms of national fuel savings. ATD-3 is primarily weather deviation, efficient deviation around weather. How do you essentially, given the weather pattern, can you choose a more direct route that is fuel efficient, conflict-free, wind optimal, and also avoids more heavily congested sectors? And that was the multi-flight common routes project. And of course, in UTM, we just did 2 very successful flight trials in Reno, Nevada, and Corpus Christi. And the flights were done in downtown settings between buildings and rooftop-to-rooftop landings and operations and demonstrating our UTM concept. However, we're not done. What I wanted to say was, in terms of what you're seeing here over the next couple of days is sort of the initial baby step into this service-oriented architecture that we want to move out on, which is how do you enable operations where airlines, given your third-party services and your own fleet operations and the way you operate your fleets, can you move the NAS towards a more federated, more flexible architecture to enable you all to essentially use your services as you want to use them? And that is what we're stepping out to in terms of the future of the airspace. And that's driven by not us, but by you all. Because this is sort of the new OV1, the new operational view of what the future of the NAS looks like. Supersonic commercial transports are coming. As a matter of fact, NASA right now, we're building a supersonic demonstrator that is low boom, that mitigates the sonic boom that's keeping us from operating. A lot of other aircraft coming in, and of course, a lot more happening in the low altitude in terms of urban air mobility and so forth. So last but not least, essentially what we want to do is enable these operations that are more diverse, complex, in orders of magnitude higher volume. We want to transform it to a service-oriented architecture, and we want to essentially use more automation or even increasingly autonomous capabilities, both on the aircraft as well as on the ground, to enable these future operations. And that's what we're moving out to in terms of the NAS transformation. And in terms of the autonomous operations, I know commercial transports, the crews are not going anywhere, at least not anytime soon. But at least on the freighter side, there may be opportunities, whether to either go to a reduced crew operations or delegated crew operations on the ground, or even no crew operations, whether it's be small freighters or even larger freighters. And What we also want to do is on the safety side, move towards that more prognostic safety paradigm. So that's what we're moving forward to in terms of what our future looks like. And I think some of the workshop breakouts that we have out here is essentially we'll be looking for your feedback in terms of, okay, we did ATD-1, we did 2, we did 3. What are your requirements in terms of what additional things that we could be working on in terms of enabling this more federated, flexible national airspace in order to enable third-party services? So that's pretty much the sort of lay of the land at sort of a higher level of what we're all about. With that said, welcome, and I'll let the team lead the rest of the discussions. Thanks, Al.